Ladies and gentlemen, thank you all very much for coming, and it gives me great pleasure to welcome you all to the home of Clean Power Technologies, where today we proudly unveil our groundbreaking technology. My name is Michael Roberts. I'm the Product Acceptability Engineer for CPT. My role here is to ensure that the technology that we develop meets or exceeds our customers' expectations in terms of performance and reliability. During this short presentation, I will introduce our Chairman and CEO, Mr. Abdul Meetha, our Chief Technology Officer, Mr. Mike Burns, and our Control System Designer, Mr. Marco Cucinotta. Each of them will explain to you more about our technology, before finally we will propose a toast to the success of the CESA system. After the presentation, we'll all be on hand to show you around the facilities here and answer any more questions that you may have. So firstly, I'd like to explain a little of the background of CPT and how we arrived at where we are today. In 2005, Mike Burns was working with the University of Sussex, exploring the possibilities of energy storage and recovery systems, utilizing steam as a medium. From his experience in engine and automotive development, Mike was convinced that a system could be developed which would offer significant gains in engine efficiency without requiring extra fuel or generating additional emissions. Meanwhile, in Canada, Abdul Meetha was studying the myriad of upcoming clean technologies to identify one which could offer realistic, genuine benefits to the widest possible markets with commercial viability. Abdul read of the work carried out here in Sussex, came over to meet Mike, and the idea of Clean Power Technologies was born. From humble beginnings in Mike's garage, CPT soon attracted the interest of world-renowned steam experts Dusan Babcock, and the concept of the first Clean Energy Separation and Recovery System, or CESA as we like to call it, was created. At this stage, the concept was to develop a steam-gasoline hybrid passenger vehicle based on a Wankel rotary engine-powered Mazda. However, it was quickly realized that this was a highly ambitious first project for a startup company, with commercial realization of this concept some way away. So CPT quickly identified another simpler and highly effective use of the technology to power refrigeration or reefer units fitted to the millions of large grocery distribution vehicles that ply the highways throughout the world. The waste heat of the truck engine's exhaust could be captured and converted via steam to electricity to power these reefer units, eliminating the diesel engines that are currently used and all the fuel consumed by it and the emissions produced. Initial inquiries with truck operators confirmed such a system would have huge potential, and in 2008 CPT went out to Calgary in Canada to make a physical study of the actual trucks and routes in operation with a large grocery chain, Safeway. The data collected from this visit enabled CPT to design, develop and manufacture a CESA system which would power a reefer unit, and this unit was successfully tested in the summer of 2009. Commercial development of this system is ongoing, and during your tour of the facility here, you'll see our Freightliner truck, which is fitted with the CESA unit, and the full rolling road dynamometer that we use to develop and test the efficiency of this system. Whilst designing the CESAR system for a large truck engine, CPT quickly identified the possibility for application to the millions of similar engines in use worldwide in locomotives, ships, and stationary applications. Of particular interest to CPT are the large engines used for stationary electrical power generation, and the most attractive in concepts are the engines which operate purely on the methane-rich gas given off by decaying rubbish at landfill sites. So CPT quickly confirmed that the CESAR technology could be applied to the exhaust stream of these landfill gas-powered engines, and that the continuous steady-state nature of their operation was ideal for heat recovery. In the US, landfill is the biggest means of waste disposal, accounting for more than 60% of waste. At the largest sites, it's predicted that landfill gas extracted can be used for electrical power generation for more than 50 years. There are currently over 500 operational landfill gas-to-power projects, producing over 1,500 megawatt hours of electricity, and there's at least 500 more candidate projects. In the UK, the amount of waste disposed of in landfill sites has reduced due to recycling projects, but in 2008 to 9, more than 50% of municipal waste and 60% of household waste was disposed of in landfill, equating to some 25 million tonnes. And this is currently producing around about 860 megawatt hours of recovered electricity. Worldwide, the statistics are harder to quantify, but landfill gas-to-energy projects are already established in countries such as Korea and Australia, and there's huge potential in highly populated developing countries such as China and India. So by recovering the waste exhaust heat energy from generators running on this free resource, the CESAR system offers the potential to produce thousands more kilowatts of cleanly produced free electrical power. For CPT, a potential market size of 2,300 CESAR units exists based on the current generated power of operational units in the US and UK alone. So this gives CPT a potential sales revenue of £360 million, or over $500 million. However, this is not including engines operating on sewage gas, and also the potential to fit CESAR units to gas flares to produce power from a currently untapped resource. The unit we see before us today has been developed using the clean energy separation and recovery technology to convert waste exhaust heat to electricity, which will be fed directly into national grid, satisfying the increasing global demands for cleanly produced power. I will now hand you over to the Chairman and CEO of Clean Power Technologies, Mr. Abdul Meetha. So Abdul has more than 3 decades of domestic and international experience in the management of ongoing and start-up public and private companies, and also business development. He is qualified as a barrister at law and received his master's degree in comparative law from Brunel University. So Abdul, please.